Today we're going to talk about synthetic substitution, which I promise eventually will make your life easier. It won't feel like it at first. Let's look at ways in which we might use this new algorithm. So if I have this polynomial function, 3x to the fourth minus 7x cubed minus 5x squared plus 9x plus 10, and I want to evaluate p of 2. Well, that's kind of a pain, right? So I have to go into this function. I have to say p of 2 is going to be 3 times 2 to the fourth minus 7 times 2 to the third minus 5 times 2 squared plus 9 times 2 plus 10. It's just a lot of calculating, and it's very easy to make a mistake. So if you do all this out, you get that this is 3 times 16 minus 7 times 8 minus 5 times 4 plus 9 times 2 plus 10. And if you do all that correctly, you should end up with the fact that p of 2 is 0. Okay? It's doable. You could use a calculator. It works, but it's long. It's kind of annoying. So let's learn something else that could help us calculate this more quickly. Okay? This way looks complicated, but it's actually fabulous. Trust me. All right, it's called synthetic substitution. We're going to calculate p of 2 using a new algorithm. Same answer we're going to get, but just a different way of getting there. All right, this is going to look weird. We're going to talk about the structure of this synthetic algorithm a little more later. When we look at division, we'll look at how this kind of comes to be. But for now, let's just practice the algorithm. So if I want to find p of 2, I'm going to put 2 into this little box right here. And then I'm going to line up the coefficients of this polynomial in order. I'm going to pay attention to the signs. So I'm going to say 3, -7, -5, 9, and 10. Okay? Now, I'm going to do a series of steps that's going to help me calculate the answer. I'm going to bring the 3 down. Boom. Whatever the first coefficient is, the leading coefficient comes down. And then I'm going to take this 2 and this 3 right here, and I'm going to multiply them. And then I'm going to put that answer right there. So 2 times 3 is 6. And then I'm going to take this -7 and this 6, and I'm going to add them. So -7 plus 6, that is -1. And then I'm just going to repeat those steps again. I'm going to take 2 times -1, and I get -2. And then I'm going to add -5 plus -2 is -7. Now I'm going to take 2 times -7, and get -14. And then I'm going to add 9 plus -14 is -5. Now I'm going to take 2 times -5, and I get -10. And 10 plus -10 is 0. The last number here, that is equal to p of 2. And that has a lot of implications for us. We will talk about that later. These numbers are also important. We will talk about them later. But for right now, if you can follow this algorithm along, then whatever you get in this last little box right here, that's the answer to your original problem. P of 2 is 0. And that's the same answer we got when we did it out the other way. When you get this algorithm down, when you know what to do, this is a very quick way of finding this answer without having to use a lot of large numbers. It keeps the numbers relatively small. So let's write down the steps to this, just so you have them recorded in your notes. All right. We're going to put the polynomial in descending order of exponents. All right. So in other words, just put the polynomial in standard form. Okay. Write out the coefficients of the polynomial in the same order. Okay, when we go through some examples, we'll look at an example of this, but if there's any missing term, like you're missing the x cubed term or the x term, you would write a 0 as the coefficient, and you'll see that in the next video. And then start with the leading coefficient and repeat the following. Multiply by whatever your input is. In our example, it was 2. And then you're going to add. So we're just going to do a sequence of multiplying and then adding, multiplying and then adding. In the next video, we'll do several examples of this so you can get used to it.